Hello class. In this lesson we're going to learn about arc length and the area of sectors. So the length of an arc is the distance on the circle around the arc. So if we took this red piece and straightened it out and measure that with the ruler, that would be the arc length. And a radian is a unit that we use to measure angles. And 1 radian is defined to be the angle measure we get when the arc length equals the radius of the circle. We're going to see how we can convert between radians and degrees later on in this lesson. So far, when we've talked about measures of arcs, we've only looked at their degree measures. But it's also useful to look at their lengths. And to figure out the length of an arc, we have to relate it to the circumference of a circle. So we can use this proportion in order to figure out arc lengths. The arc length divided by 2 pi r, which is the circumference of a circle, equals the degree measure of the arc divided by 360 degrees. So this is really just a proportion of the form part to whole, right? The whole length around the circle equal to part to whole, the whole amount of degrees around the circle. Now if we multiply both sides by the circumference, we end up with this equation on the right-hand side. So if we plug in this information into what we learned on the previous slide, we can figure out the arc length. So the fraction of the circle that we're looking at is 60 over 360, right? The degrees cancel out. And 2 pi times 10 is the circumference. So we're looking at 1/6 of the entire circumference, which is 10 pi over 3 centimeters. In this example, we have concentric circles, and these minor arcs here all have the same degree measure, but they're all different lengths. So what are their lengths? Well, the smallest one is the same as the previous example, that's 10 pi over 3. The medium one is an arc length of 20 pi over 3, and the largest one, 30 pi over 3, which is equal to 10 pi. In this example, we're given the degree measure of the arc and the arc length, and we got to figure out what the radius is. So if we plug into our equation, we end up with this, and we got to solve for r. So if we simplify, we get 1/3 pi r equals 5 pi. Divide both sides by pi, right? Those cancel out. And multiply both sides by 3 to cancel out the 1/3, and we get 15 centimeters. So if we're given 2 out of these 3 bits of information, we can always figure out the third one using our equation. So we know that if we're given a degree measure between 0 and 360, we can find an angle with that measure that exists. And a similar thing holds for arcs. If we're given an arc length between 0 and 2 pi r, we can find an arc of that length on a circle with that radius. Now we also saw that when we have adjacent arcs, that we can do something with their measures. If we add their measures together, we end up with the degree measure of the larger arc, right? So this equation holds true. And we can do something very similar with arc lengths. If we have adjacent arcs, we can add the arc lengths of the smaller arcs together to find the arc length of the larger one. If we have any minor arc, what is the sum of its length and the corresponding major arc length? Well, if we add a minor arc and its major arc together, their lengths together, we end up with the circumference. So it must be 2 pi r. Now, could we have an arc length of 0? Well, that would imply that the arc was just a single point, but we know that an arc has 2 different endpoints. So arc length has to be greater than 0. Could it be equal to the circumference? Well, arc length just refers to a portion of a full circle, so it can't be the entire circle. So the arc length is always between 0 and 2 pi r. So we've already seen the definition of a radian. In order to find the radian measure of a central angle, we divide the corresponding length on the circle by the circle's radius. So for example, what would the radian measure be for 360 degrees? Well, 360 degrees corresponds to the entire circumference of the circle, so it would be 2 pi r divided by r, so that would just be 2 pi, right? The radii would cancel out. So what would 180 degrees be in radians? Well, that would be half the previous result, so it would be pi radians. And this is a relationship that we use normally when we're converting between radians and degrees. So if we want to do that conversion, we use this proportion. Pi divided by 180 degrees equals the radian measure divided by the degree measure of the angle. So I'd like you to try part A here on your own, and then we'll come back and let's look at my solution, and we'll do part B together. So to find the arc length, we first have to find the measure of the central angle here. So the corresponding inscribed angle is 60 degrees, so we double that to get 120 degrees for our central angle. So we put that information along with our radius into our equation for finding arc length, and we end up with 24 pi. So the central angle here measured 120 degrees, and we want to convert that to radians. So we put that into our proportion, and I put an x here for our radian measure. And let's see, multiply both sides by 120, and we end up with 2 pi over 3. So 2 pi over 3 radians. Now, just like arc length was related to circumference, sectors are related to the area of a circle. And a sector is what we get if we take a part of the disk out that's formed by an arc. So we go from the center of the circle to a point on the circle and look at that radius, and we sweep out a whole section of the circle. And then we stop, and then that piece that we're looking at is the sector. So here we have a circle, and we know its radius. What is its area? Well, the area of a circle is pi r squared, so that'd be 100 pi square centimeters. All right, what about half the circle? What would that be? Well, it would just be half of the previous result, right? We know in a semicircle, there's 180 degrees, divided by 360 degrees, and that gives us 1/2. And what about a quarter circle? Well, similar idea. 90 degrees in a quarter circle, so that divided by 360 gives us 1/4. So 1/4 times this area gives us 25 pi square centimeters. So how can we figure out the area of a sector when its arc measure is 60 degrees? So that's not nice like 1/2 or 1/4, but we can still use the same idea. So 60 out of 360 degrees is 1/6. So multiply that by our area, and we get 50 pi over 3 square centimeters. So to find the area of any sector, this is analogous to what we did for finding arc length. You look at the area of the sector, divide that by the area of the circle, pi r squared. That's going to be the same as the measure of the arc divided by 360 degrees. So part to whole, part to whole. The only difference is that now we're just looking at area. So here we know the measure of the minor arc, and we know its area. What's its radius? So here's one where we plug in, and we work backwards to find the radius. So 60 degrees over 360 degrees is our fraction, and here's the entire area. That equals 24 pi. So this is 1/6 pi r squared is 24 pi. Let's see, if we divide by pi on both sides, those cancel out. And multiply by 6 to cancel out that 1/6. And r squared is 144. So to solve this, we take the square root, and we end up with 12. So the radius has a length of 12 units. In this lesson, we learned about arc length and the area of sectors. Thank you for watching this video.